Welcome to True Projects. In this video, we are going to explain about a project titled Ocular Disease Recognition using AI. In the past few years, the realm of artificial intelligence has witnessed the remarkable progress, particularly in its integration within the healthcare sector. This incorporation of AI has paved the way for the novel strategy to enhance the disease diagnosis and the treatment. Ocular diseases encompassing the condition that impact the eye and visual system have garnered the widespread attention due to their substantial influence on the public health worldwide. The timely and the precise identification of these elements is paramount to preventing the irreversible vision impairment and facilitating the prompt medical intervention. Against this backdrop, the utilization of AI for ocular disease recognition has emerged as an encouraging avenue, holding the potential to transform the field of eye care and elevate the patient outcomes. By harnessing the AI capabilities, this approach strives to reshape the traditional practice and contribute to more effective disease management within the domain of ophthalmology. The core aim of this study is to establish a robust and effective AI-driven framework for ocular disease recognition. By leveraging the capability of the machine learning and the deep learning algorithm, our objective is to forge a model proficient in precisely identifying the diverse ocular conditions, from diagnostic imagery including the fundus photograph, optical coherence tomography, and the retinal images. Our system is designed to achieve the several pivotal objectives. First, aim to enhance the early detection by automating the recognition, facilitating the timely intervention to mitigate the risk of irreversible vision impairment. Furthermore, the AI algorithm potential for meticulously scrutinizing the extensive data set can potentially surpass the human accuracy, uncovering the subtle markers and the patterns indicative of various ocular diseases. Additionally, the system aptitude in accurately categorizing the ocular disease can aid the ophthalmologist in tailoring the personalized treatment strategy, optimizing the therapeutic outcome. These are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. The project starts by importing the necessary libraries and packages, setting the groundwork for developing the AI-based system for recognizing the ocular disease. And the next one is exploring the dataset. The dataset containing the images of ocular disease is explored to understand its content and the structure. And the next one is visualization of labels. Labels associated with the images are visualized to gain the insight into the distribution of different ocular disease categories within the dataset. And the next one is image tagging. Images are tagged with the relevant labels corresponding to the type of ocular disease they represent. This tagging is essential for the supervised learning. And the next step is image processing. Images undergo pre-processing steps such as resizing, normalization, and the noise reduction to prepare them for the model training and the analysis. And the next step is extracting the image to the train and test. The data is split into the training and testing subset, allowing the model to learn from a portion of the data and evaluate its performance on the other. And the next one is extracted value stored with the NumPy array. The pre-processed image data is organized into the NumPy arrays for efficient handling during the model training and the evaluation. And the next one is data visualization. Visualizations such as histograms, scatter plots be employed to gain the deeper insight into the characteristics of the data and its distribution. And the next one is flatten and shuffle the train and test data. The image data is flattened and shuffled to ensure the randomness in the training process and to prevent the bias. And the next one is building the model. Here various models are built with of machine learning and deep learning. For the machine learning, the first model is RF. It stands for Random Forest, a machine learning ensemble method that constructs a multitude of the decision trees during the training and outputs of the mode of the classes of the individual trees. It is known for its robustness against the overfitting and its ability to handle the high-dimensional data effectively. And the next one is SVM. It stands for Support Vector Mission, a powerful classification algorithm that identifies an optimal hyperplane that best separates the different classes in a feature space. SVM are particularly effective in the cases where classes are not linearly separable and can handle both the binary and the multi-class classification problem. And the next one is voting classifier. It combines the prediction from the multiple models like of gradient boosting decision tree, and the XGBoost. Voting is employed to determine the final prediction, allowing the model to capitalize on the strength of each constituent model. And the next one is deep learning. Here we employed the first one is Inception V3, a deep convolutional neural network architecture known for its performance in the image classification. It features the multiple layers with varying kernel sizes to capture the feature of the different scales within the image, enabling the precise object recognition. And the next one is MobileNet, a lightweight deep learning model specifically designed for resource-constrained environment. It employs the depth-wise separable convolutions to significantly reduce the number of parameters and the computations while maintaining the high accuracy in image classification. And the next one is user uploads an image for analysis. Here we used a Flash interface as of application to provide the image of ocular condition for analysis and diagnosis. And the next one is the given input image is processed. The input image undergoes pre-processing similar to the training image to ensure the compatibility with the model input requirements. And the next step is the trained model is used for predicting the result. The trained model processes the input image to predict the ocular disease based on its learned feature and the pattern. And the last one is final outcome is displayed. The project concludes by presenting the prediction outcome to the user. This typically includes the predicted disease category along with the confidence score, providing the valuable insight into the condition of the eye based on the uploaded image. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The images folder containing of the testing and training folders containing of various images with the labels within it. And the folder containing of those images within it. And the pre-processed images folder containing of images after the pre-processing step. And the sample folder containing of the images that will be used to test the performance of the model. And the static folder containing of the uploads, images, CSS, JavaScript files within it. And the template folder typically contains of HTML documents. It includes of home, index, results, sign in and sign up pages within it. And the app is an PY file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an IPYNB file which contains the combination of code, track, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file, appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command, that is cd space and paste this code folder path. Then by this it will change the current directory to the code folder path. Here we need to write a command, that is python space add.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here it redirected to this page containing of some information, and the title of the project. Then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I am clicking on the sign in page. Here it redirects to the sign in page containing of username and password. And then click on the login button. Here it will redirect it to this page containing of the choose file and upload buttons. Click on the choose file button. Here it will redirect it to choose this folder containing of various images within it. I am selecting one image and then click on open button and then click on the upload button. Here it will redirect it to this result page and containing the result as of prediction, as you have normal funders based on the input image. And then click on the try again button. Here it redirected to this file containing of choose file and upload buttons. Click on the choose file and then select one image and then click on the upload button. Here it redirect to the result page and giving the predicted result as of other disease or abnormalities. In this way, we can recognize the ocular disease by using the AI. And in conclusion, the application of AI in ocular disease recognition represents a groundbreaking advancement in the field of ophthalmology. The development of a sophisticated AI model with the capacity to accurately diagnose a wide range of ocular conditions hold the tremendous promise for improving the patient care and the overall high health outcome. By expediting the detection of ocular disease and providing the more accurate diagnosis, our powered system can significantly impact the life of millions, safeguarding their vision and enhancing their quality of life. However, we acknowledge that there are challenges to overcome, such as data quality, interpretability of AI predictions.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.